Hello. Did that work? Working. Did it work? Okay, great.
You said you wanted to see our notes from last week, a few people. I'll do that now or later.
I need to learn how to use projectors. Sorry. The notes from last week was intended to be stuff you could share on Canvas for everybody else, including us. Yeah, for everybody. So if you have notes you'd like to share, just post them on Canvas. You can either, if you can scan them, that's awesome. But if you can't, take a photo. Just post them out.
There's just a lot of screaming and fighting about that stuff. Very informative.
Cool. The screening was or the lecture? Okay, good.
He does have a strong projection. He walks around the room. He's kind of testy, you know, but it's not like it wasn't screaming like.
Okay.
You mean his oral delivery?
Yeah.
In the size of the room
Is powerful.
Yes.
Has anybody been here? Has anybody been here long enough to remember Lawrence Touchy? Was a faculty here. He actually passed, but he puts gives to share. He'd be lecturing at one end of science in like a small room, and you'd be able to hear him at the other end. It was just wow. So, yeah. It was. Well, I hope it wasn't too intimidating. I hope it was informative. I hope that lecture helped to maybe connect some dots between the coding stuff that we do and how it might actually work on a computer. And if it didn't, that's okay. How about the reading? How was the reading? That chapter 1 of Patterson and Lacey?
I enjoyed it.
Yeah. Okay. Cool. And if you notice, the problems were more towards the beginning of that section, so I wasn't as concerned with like you figuring out how the wafer size is gonna. Sorry, the performance stuff. I wasn't as concerned about that. If you decide to go into electrical engineering, especially on the digital side, there is a very high possibility you will take a full semester course that uses exactly that one, that Patterson. It has been for many years the book on computer understanding. But if you don't, you may never see that again. And that's okay. So don't stress about that. Ultimately, like the spirit of this class is to get you to use the MATLAB as a tool to accomplish your end goals. And the stuff that was covered last week isn't necessarily key for that. Cool. If you have any more feedback on that lecture or want to talk about stuff, just let me know. You can send me a message on Canvas or some other. Cool. So let's talk about exam 3. I know you guys are all excited to hear about it and probably frustrated in some way or another about exam. And that's totally reasonable. Yeah? It was longer than I had hoped. I did not want that exam to take as long as it did. So, at least my hope was that it wouldn't take that long. So I apologize for it taking as long as it did. In general, across the board in terms of the problems, I think the performance was decent. Like it was kind of around what I was expecting. Okay? You may not feel that way about your own performance, and that's fair. I want to talk a little bit about sort of common themes from that exam and just kind of ideas I want to reinforce about how we do some of these programs and like sort of main lessons you should take. Okay? I don't want to spend a lot of time on those because I feel like some of you have got it. I don't want to swirl all folks of you who've got it, but I do want to reinforce it for everybody. We will then talk about the strategy for extra credit on exam 3 because, like I said in that Canvas post, I don't look at exam 3 as behind us. I look at it as like, hey, we struggled with exam 3. It's okay. Let's see if we can figure it out now. Maybe these problems will appear again on exam 4, that sort of thing, or something similar to it, maybe on exam 4. And in the spirit of that, I want to offer some extra credit. I feel like it's fairly generous in the points world, but it's not going to be generous in sort of the grading scheme for it. Okay? Yeah, Philly,
Is exam 4 the final?
Yeah. Exam 4 is our last exam. So let's start with Let's start with the grades distribution on it. Yeah. How many of you have seen the histogram already? Because I just posted it. Okay. All right. Yes. So this is like we've done in the past with our histograms. This is by problem number. Yeah. Okay. So, ultimately, like, this isn't horrible. If you compare it to your calculus or your physics or other things like that, these spreads aren't that bad. This one, this tail's a little bit longer than I think one would want. If you understand what I mean by the tail. This one and this one, they seem okay. And then this one clearly was a challenge. Right? And I think I was expecting that. Like, that was not a surprise to me, right? This is like, here's a challenging problem. Let's see what we can do. I didn't expect, what I did not expect on the exam was the amount of time these earlier ones were going to take, leaving many of you with not quite enough time on this one. Okay? Some of you went the opposite strategy, which is you spent a lot of time on this one and then sort of didn't have an opportunity to come back, right? And that's okay too. That's part of that is part of test taking, the reality of testing. I've shared this experience with you, I think, before, but I think you're going to find that your exams, after you transfer, being pretty damn worse than this. Yeah. So just be sort of prepared for that. Now, what that might mean is the distributions like this, and then the faculty is like, all right, I'm just going to curve the thing. This bulge moves to here, this bulge moves to here, and that's just the final. Like, you think you got a 20 out of 100 on an exam, and you actually ended up with a B. Like, how's that possible, right? This happens all the time. I don't want to curve this. What I want to rather do is give you guys a chance to do the extra credit. The extra credit is basically going to be this one, the Connect 4 problem, and this one, the crop image problem, which we have now seen twice. The extra credit is going to be exactly those problems with my clarifications and a couple of sort of constraints around it. So let's talk about lessons learned because it connects with my clarifications on things. Okay, functions. From the scoping perspective, scope meaning variables, right? Your workspace, memory space. What is a good way to think about a function?
Maybe a way to save some space.
Certainly not our goal. Do you guys remember this concept of abstraction? Sort of the abstraction, right? So there was code abstraction, as well as variable isolation, right? What stays inside your function stays inside your function. So let me just draw a box for functions, yeah? This is your function. We had talked about some rules for our functions. One of the rules was we really don't want to do any display to the screen. You guys remember that one, right? So let's add that in here. No display. That includes, I should say, let's be really clear. Let's be more clear. Let's say no visual output. That means no display to the command window. suppress the semicolon. Remember how MATLAB has this really annoying, sometimes helpful feature, but often very annoying feature that every command has some stuff that skews the screen. And suppress the semicolon. No IM show, no plot. Unless the problem is explicitly asking for you to do something different, right? Which there will be some occasions where that's the case. In general, I think we want your functions to be kind of tight in this box. The only thing that goes in or out of the function are right, and we think of those as when I call it, I'm going to send it some arguments, parameters, variables, exactly. So the only thing in are variables. And yes, we can say parameters or arguments. And then the only thing out is it's also a variable, right? And if you look and think back at that function declaration line, that function declaration defines the name of this box, the things that are going to go in, and the things that are going to go out. Right? Now, when you're writing your function, of course, you need to figure out what's going on. So you're going to need to do all this, right? So I'm not saying don't do this while you build your function. What I'm saying is when you're done, this stuff needs to be suppressed. It needs to be clear. So what are some things I saw in the functions that I definitely think cause problems for some of you? Okay. I saw in a function that the function was called from inside the function. What does that mean? Recursive. Yeah, it basically turns it into a recursive function. What that means is if this function was called Bob, somewhere in here I said Bob. Right? And on this exam, we didn't have any recursion, right? If you call Bob inside of there, either you're changing the value of Bob by accident, or you're calling it, you're going to have this endless loop. So unless you know you're doing recursion, you're more or less have no need to call this function inside of it. Is that fair? Yeah? Okay, good. What else did I see? I did not mark any points off for this, okay? And I realized it was because I did not make it super clear on the cropping function problem. But for the extra credit, okay, I saw IM reads inside of here, okay? If you look at the problem statement, it pretty much says, I want a matrix coming in. That the input is a matrix variable coming in. Okay? I saw this enough that I was like, okay, that's fair. Clearly, the problem statement was not explicit enough on this point. So I did not take any points off of it. If that is the case on yours, please let me know. That was not my. So I worked around that. Okay? So I tested these in two ways. So if you had the matrix method, I tested it that way. If you had the IM read method, I tested it that way. For the extra credit, and I've made this very clear on the extra credit, there should be no IM read in your function. Your function should just take that matrix in, cut the matrix up, and send it out. If you recall, at one point, we did talk about how the image was irrelevant to this cropping bit, right? It was take any matrix. It doesn't matter if it's an image. It could be a matrix of dollar values or whatever. And all I'm asking you to do is cut out a section of that matrix. It just happens to be an image that was kind of a fun thing we were doing. Ultimately, this is just matrix comes in, matrix gets cropped, the resulting cropped matrix gets sent out. So a lot of great ways to do it. There are many ways to do it. And it was really nice to see how many different ways people had tried to do that. Okay on that? Why is it that I might not want IM read here? Yeah, what if I want this function to work on things that are not an image? Right? What else?
And the image.
Sorry?
You're limiting yourself to a certain
Yeah, well, okay, so fair. People were pretty clever about it. The IM read followed by a variable name. So that variable name gave, in most cases, there was a couple that I saw hard-coded. That was harder to figure out. But in most cases, that the variable name that was here for the matrix was interpreted as the file name and passed to an IM read, which is okay. Like I took it's fine. No problem. But this, so that actually connects to the second thing, which is it insists on that data being in the file. It insists on that data being in the same folder that this thing is in, right? And so it adds actually kind of like, if you think about it, in terms of your function being flexible, utilizable in all sorts of circumstances, it makes it a little bit harder. If it is an IM read, let whoever's doing the calling, do you guys understand what I'm saying, what I mean when I say whoever's doing the calling?
The user.
Sometimes it's the user, sometimes it's a script, and sometimes it's another function altogether. Yeah. So the caller doesn't have to be a human. Okay? The caller could be a script. The caller could be a function. Okay? But the caller, its responsibility is saying, I want to run this function, and I'm going to give this function these parameters. The function then goes and does its stuff with those parameters. And when it's done, it takes its output values and it sends it back to the caller, right? Whoever called it. Okay. You okay with that idea? And so when I actually grade these, the caller sometimes is me. And sometimes it's a script I wrote. And sometimes it's a function I wrote. And for many of the problems, it was all three of them at once, right? Like I would try to do a first pass with a script, wouldn't come out, so I'd have to go look at it a little bit, then I became the caller. In fact, in many occasions, I would change your code a little bit to try to get it to run, to get it to the next steps. And hopefully, I hope Canvas is making it so you can see my feedback, because I actually comment the code itself. You guys see the highlight on the code? You should go into the problem in Canvas. I am highlighting the code with explicit comments for the exams. Yeah.
Can you demonstrate what you're
I can't because I have no way of, I don't know what your view looks like. If you want to show me your computer, I can show you what it looks like.
I'd show you mine, but I don't have anything commented like that.
So I'm happy to show you, but I can't do it. If somebody wants to volunteer to do it.
Yeah, you can log in on your account and show you what you gave it to us.
Yeah.
Anybody have a laptop?
You can log into this one, I don't mind. Do you have comments in here? Has to be somebody who has comments.
Well, especially like, it's not on a code level, or at least I don't know where to find it.
So if you go to the review page for the assignment, you'll see your submission, and you should see then the rubric somehow. And on your submission, there'll be annotation. Not guaranteed, but for many of you.
I think you press the little button up in the right-hand corner that says review submission. And then the actual program, the script that you submitted comes up in a page form, and then you can see those comments once you're
Okay.
looking at it. I'll give it a try.
Okay. I hope there's a way for you to see it, otherwise I'm wasting my time putting them in there.
No, you can see it.
I've had another teacher do that, and it takes a little bit of learning Canvas, but yeah, it's possible to see.
Okay. Well, let's figure it out. Yeah. Okay. Do we actually want to try to do it right now up here? Or let's figure it out later.
Yeah, I'll hear.
Let's figure that out later, okay?
Yeah, I did.
Okay, so you can teach us at the break. How to do it. No. I mean, maybe if you have a VGA port on that thing. Which is unlikely. Okay. Any questions on this so far? Yeah.
So you're saying you don't want that function to give you any greater output because that's generally what people with computer computers do?
So I'll reiterate this. If your function is going to be called 10,000 times by some other script, what's the value of that?
You get a whole bunch of junk shown.
And can any human process that?
Probably not.
Right? And do I want to pause? Okay, so if I need to run something 10,000 times, do I want to sit there and look at it, pause, next, like find a way to page through it? No. What I want to do is I want to write a script. Actually, here, I can show you. Sometimes it's easier to demonstrate, right? like what I really want is a way to just say, run your script, run your function 10,000 times, and I want the caller, the script that's calling it, to validate those results, to say, this result makes sense, this result makes sense, this result doesn't make sense. And in those cases where it doesn't make sense, maybe it alerts me somehow, puts that information in a file or something like that. But in general, all that stuff going to the screen is very hard to process or make use of, yeah? Especially in a function. Now, let's say you really want that output, right? Because sometimes you do. Fair enough. Let the script take it, right? The function, once it's complete, is meant to be perfectly working. There's no issue for it. There should be no debug. And it's this thing, and I just trust it. I trust this function to crop my images, period. Right? If I happen to want to see some of the output, I can do that in the script that's calling it or the function that's calling it. And the easiest way I can show this is maybe the example with the checkers. You guys want let's kind of use this. At the risk of sort of like this, okay, my goal is to just show you at this point why you might want no output, one, and then also kind of a way that functions can be called and there can be a nesting, if you will, a depth of this. Okay? So what I have tried to do here is basically write a script that will run your code. This one specifically is connect 4, okay? And if you guys remember, Canvas does this thing where it watches all the file names, right? As your last name, as your student ID and stuff. And that violates MATLAB's function rules, right? MATLAB's function rule says the file name must match the function name, right? So all this first part is doing is going through a folder and saying, give me all the files that are in that folder, and one by one it takes one and it moves it to another folder. So, you know, it says student Bob.m now becomes, it's in a special location where I can do the testing, is now just the check connect 4.m. That's all this first part does. And then after that, it goes down here and it says, I'm going to play the game. How many times am I going to play the game? So what I'm trying to do here is have 20 games run at once on the Connect 4 that you the check Connect 4 script. 20 games, which could have up to what, 48 moves? How many moves are there, Max? So 42. So 20 games times 48 possible moves. That's how many times I'm going to call your check Connect 4 script. Ultimately, right? Because I want to check it after every play. So you're going to play a total of 20 games. Each game could go up to 42 moves. And after each move, I'm calling your check connect. So sort of, if you have a boatload of output in the middle, it makes it a lot harder for the user at this top level to see like a summary of what's happening, right? So that's kind of like sort of giving you the scale of the motivation for why we want to suppress the output. This goes and calls a script that says play connect 4 game. Okay, and then this is very similar. If you remember the play connect 4 script I gave you guys, right? This is very similar to that. It basically plays connect 4. The only difference is, at the very end, it calls 2 different functions. Right here. Okay? It calls your function, which is this one, and then there's a solution function. Okay? And then this script, because I do want to get a sense of how the progress is coming along, is going to compare these 2 solutions and tell me if it was a pass or a fail. And it's going to give me a little information about this. So this script is taking care of giving me the information that I've chosen. At some point, I can say, actually, I don't want all that information. I can get it out of here. If it's in your function and it's outputting, I have no control over it. Right? And it's not just about me. This is about, you're an engineering organization. You build a function that dumps all this stuff out, right? and your colleague is like, hey, I don't want all that output, I just need the results. Right? That's the kind of situation. Yeah. Now, when you get into more sophisticated stuff, there are ways to, sometimes people call it like log level or debug level. There are ways to call a function where the person script or whatever calling a function can actually specify different levels of log or debug information. The default is you don't get anything, but maybe you're curious about how stuff's not really working so well. So one of the parameters might be log level. Like how much detailed debug info do you want? Does that make sense?
What do you mean log level?
Debug level. Like, do you want a little bit of debug information, some stuff displayed to the screen? Do you want a lot of stuff displayed to the screen? Do you want every single command's output to be displayed to the screen? Okay, so that sometimes is called log level.
So in that instance, are there just like conditionals that exist within the function?
Yeah.
And there's like the same script over and over and over inside the function, but based on different levels of output?
Oh.
It's like,
It's embedded. It's basically if this was meant to be some sort of information for the screen, right here it would say if log level equals whatever, then display it. So it's not that the function repeats, the code doesn't repeat. It's just that there's a conditional wrapped around every output. And common log levels are like error, warning, debug. Those are common. Sometimes they're just verbose, not verbose. I don't know if that helped to like provide an example of why we don't want to have output from our functions.
The example you gave of the engineering corporation, you don't want your buddies to do all the crap. That's the very practical explanation.
It actually might be more your buddy doesn't want to do all the crap, not
Yeah,
that
exactly.
you don't want your buddy to do the crap.
Yeah, exactly.
But again, like when you build this thing, you need that display stuff. I totally get it, right? Like when you make it, you need it. And you should have it in there. But by the time you're done and you deliver it, it should be commented out. I actually think that wraps up my sort of common stuff. Yeah. So let's just talk about the extra credit. Shall we do that?
Yeah.
Okay. All right. So I had toyed around with this idea of like the extra credit being the same problem and then averaging with the grade that you already got. And I was like, that's just too complicated, right? So there are 2 extra credits on Canvas. And for what it's worth, I have talked to a couple students to kind of get a sense of what we, what we should do. And I think I'm comfortable with what I'm proposing. Okay. So like I said, the first one is exactly the cropping problem, okay? I want to be super clear here that that image matrix parameter is meant to be a matrix that's going to come into your function, not an image. So please make sure it's that it is ready for a matrix to come in. You do not need to do any IM read, and your function should not display any visual information. Okay? The rest of this is very similar to what you just saw. I think the parameter, the one thing that I want to be super clear about is it's 30 points and it's all or nothing, okay? If it works, you get your 30. If I have to sit there and edit the code to make it work, it's not going to get the points, okay? So I'm going to be able to test the completion without any modifications. Any syntax or runtime errors, yeah, okay? And you should be able to see that by testing it yourself, right? Must be well commented, must use function. Okay? May 6th is Monday at 5 p.m. Okay? So that gives you tomorrow on campus, if you have time. Because the weekend, I know some of you don't have access to MATLAB on the weekend, so that's why I made it end of day Monday. I checked the Cloud 213 lab is available all day Monday. Okay? That's this one. Oh, one other thing. My expectation, unlike the homeworks where I'm happy for you to collaborate, I really do not want you to collaborate on this. Okay? I want this to be your own individual effort. I have to trust you all for that. Okay? But it's 30 points towards the exam grade. So it's not like 30 points somewhere else in the homework or something. It's 30 points towards the exam. The other one is for Connect 4. Or grab it, whatever. That's 80 points. Same thing. 80 extra points straight to the exam grade. Okay? Must be coded independently. Same exact framing. The main thing here, most of you were pretty good about this, but just please no visual information. This Play Connect 4 script is there for you to test it. If that script doesn't work for you, like if it doesn't run your code properly, that's a key indication that it's not going to work for me, right? That's it. That's an example of how it's being called. So that's for you to totally use. Okay, one last thought. Okay. Those of you who have had me for classes before, you should know that ultimately at the end of the day, my grading tends to be very reasonable. Like, I will look at the grades at the end of the semester and go, you know, something's wrong here. These people did not deserve B's or C's. They deserve A's. Alternatively, I do look at some of them sometimes and go, like, how the heck did this person get a B? I don't think it was a B. Like, they did not show B level work. Okay? So I know I say like, hey, the grade's the grade, the grade's the grade. I look at it as a class, as a whole at the end of the semester, and I try to be sane about it. Okay? I'm not the kind of guy that's going to fail the whole class. You will encounter people like that in the future. Trust me. Okay? And I'm not here to ruin your transfer career. Really here to like give you guys a kick for the next step. And ideally, hopefully, also make you better engineers in the class. Okay.
I have a question about the help. I wasn't really too sure what that meant.
So if you recall, when we talk about the function declaration, MATLAB has a super nice feature. The comments right below the function declaration become part of MATLAB help. Meaning if someone types help in your function name, that little bit of comments appears. Yeah? Let's see if I can show you an example. So this is not very good, but here. Okay. So you see the function declaration line? You see the comments that are abutted to it? That little bit of there becomes part of the help. So if I go to the command window, I say, whoops. And that is really, you know, back to the workplace situation example. You write a function that's awesome, it's going to solve everybody's problems, and you want to share it with 100 people. They can go help, figure out how to use it. Like, it should include information about how it should be called, what it's going to do. Not every programming language gives it to you that easy, but MATLAB does. But every programming language has an infrastructure for that. Okay. Yeah.
I didn't understand what the like the negative 99.
Okay, good question. Let's talk about that. So let's look at it in, I think the crop example is a better place to start. So let's look at the crop example, okay? Oh, geez. Are we going to have this problem again? Somebody is using something on these boards that they're not supposed to. That person should be punished. So assume this is your image, okay? Or not even image, just assume this is your matrix. Okay? 0, 0 over here. Let's just do 100, 100 over here, right? 100 row, 100 column. Yeah? If somebody calls the crop function and specifies a point here as the bottom right corner and a point up here as the top right corner, that's an example of an error condition, right? Because they've given you a matrix that's this big, and then they've specified something like 75, 150, which is outside of the thing. Like, how is your script supposed to handle it, right? And so what you want to be able to do in this function is send a message back to the caller that, hey, something's wrong, there's an error. Okay? Now, you can make a nice statement that says, hey, shit hit the fan, but that's a character string, and it's hard for computers to handle character strings. And they don't know, they cannot translate that English, right? So what you can do is come to an agreement to say, hey, there's a special number that I'm going to just say is an error. And oftentimes people use negative numbers if negatives are not expected as a real value. And so you might say, okay, negative 99 corresponds to a value out of the bounds. Okay? And what you would do inside of your function, you'd be like, okay, this value looks okay. Check mark, no big deal. Check the next value. Oh, this value is bad. At this point, your function can basically stop doing all the hard work, but it must return whatever that return variable is. So in this one, what was it called? New matrix or new image matrix, right? So new image matrix. Right? Normally, it has the actual matrix that you cropped, right? But in this error case, you go, something's wrong. I'm just going to put a negative 99 in here, and I'm going to send that back to the caller. And then I let the caller decide what to do with that negative 99, right? If the caller is some super fancy script, it gets that negative 99 and goes, oh, maybe I did something wrong. My database is bad. I missed a line. I don't know. The caller does something. It figures it out, right? It's not a syntax error. It's not a failure in MATLAB. It's something that can be handled internally, right? And the calling script can go do and figure out something. You could be more sophisticated than this. You could say, okay, value greater than the bounds is negative 99, and then maybe negative 98 means value smaller. Maybe negative 97 is coordinates are not numbers, right? You can imagine somebody accidentally passes a character as a coordinate, right? It's supposed to be 75 and 150, but somebody decides to give you, that's a character string. MATLAB does not know that is, you and I know we see a number here, right? But computers don't know this is a number. They see this as a series of characters that has zero meaning. Okay? And so if somebody gave you this as a parameter, you can say, oh, that's an error. So that's, let's call that parameter not numeric. So that's kind of what it might look like for crop image.
I was wondering if you could see like an example of the code for that check or something.
To check if it's an integer?
Yeah, to check that. I've been struggling with that.
Yeah. Hello. So most programming languages give you actually really nice, easy features to do this.
Yeah, it was too small to put it in.
Sort of. I think I know. So let's do this.
Yeah, exactly.
It's not checking for if the number is an integer. It's checking for the integer data type. So is your question, you want to actually check for the value being an integer as opposed to having decimal places? Or is your question to check for integer data type?
I guess to make sure, it could be like half a pixel, just to make sure that like.
Okay, great. So what you really want to check for is the value that's in here a whole number? Is that fair?
Sure.
Okay, so the easiest way to do it is to divide by 1, right? And use the I think it's called modulus. Let's see here. Hold on, sorry, let me clear. Let's see. Okay. So modulus is like the remainder of a division, right? And so what you could do is say, take your number and divide by 1, and what it'll give you is the whole value, and then it'll give you some remainder, right? And I think what you can do then is check to see if the remainder is 0 or not. This is one way to do it. There should be other ways too. So let's try this, okay? By val equals 4.67, right? And then quad by yeah. And so if my number is an integer, I would expect this to be 0. And if my number is not an integer, this will be non-zero. Cool. We'll try it. Okay, here, we can just do this. Mod 6.1, right? The result of the modulus is 0. Modulus is just remainder. Modulus just means remainder after division. I can put it here. I still get 0. But the moment I add anything, well, this is MATLAB rounding.
So then if the answer is not 0, you have the issue.
Yeah, so that would be a way to check to see if your value is a whole number. That's one way. There are other ways.
So the two cases that we checked is if it's well, I mean, 3 cases which is out of bounds, it's not connected
So I gave these as examples. I wasn't too picky about what your error checking was for. You can get really crazy in like all the different possible cases that could come out, right? You could complain if these two are on the same line, perhaps, or the same line this way or this way, right? And so I wasn't looking for all those cases by any means, right? But just, to see if part of it was to see what you approached as an error. What did you highlight? Right. So none of my automated stuff checks for that, with the exception of the first one, which was the, I think I checked for if it was underground. Thought that was a pretty obvious one to look. Like a negative altimeter reading, right? And if, let's say this was a real world thing, right? You're building this code for your spaceship, and suddenly you start getting negative values. Are you going to keep saying you're in the troposphere? Right? You want your code to be like, oh, there's a negative value. Something's probably broken. Most likely, it's not that the rocket went underground. Most likely, it's the altimeter that's on there failed, like the thing that's doing the altimeter reading. Right? And so you can imagine, actually, did anybody come and watch the presentation for the rocket? What's his name? The guy who visited 10A just not too long ago. Talk about the rocket stuff. He was at Cal Poly Pomona. He was a City College transfer student. He talked about this a little bit too, right? You put multiple altimeters on there, right? And what your code's going to do, maybe you want to average these altimeters to get the right value, right? But if one of them is giving you negatives and you're going to start putting that in your average, like that's an error. That's a serious error, right? Because one altimeter tells you you're at 10,000 feet. The other altimeter is telling you you're at -5. You don't want to average those values, right? So this is part of that error chain. You've got a function that gives you, this call, and it comes back and it's like, hey, something's wrong. Now, in that case where you're doing averaging, you might actually want to do other checks to see, like, hey, are all my altimeter values within the same margin of error, right? I mean, that's getting more sophisticated. I'm not asking for that. You can see how this process of what we're trying to get at becomes more and more valuable. Joe, did that answer your question about the negative?
Yeah, I honestly didn't know what you were talking about. So you have the -99 on the left.
Sorry, this is not MATLAB. This is like more algebraic. If you were going to, this is not a variable, right?
Right.
This is just my text. So I'm just describing to you that -99 means this, -99 means this. If you're going to do this as code, it would be you would have some variable equals -99. Actually, like what you see. This is what your code would look like. This is trying to describe to you the scenarios.
So you have like an if statement, if new image matrix equals -90 display.
Your function is going to put this value in here based on some other ifs that I didn't draw. Right? But that if is if your value is outside the bounds. There's more you have to build on.
You're going to send it back to the caller.
Yeah, let the caller take care of it however they want to. Yeah. The caller may not display it either though. The caller might say, oh, I got a -99. I know I need to do some other stuff. Any other questions? You don't have to do the extra, but you should do it. And it doesn't matter what score you got on those problems, you can just do it. So it can make up for lost points in another problem. Okay. You answered my question. Yeah. I'm not gonna, it's too complicated to canvas anyway, but I'm not forcing those points only to be for those problems. And the reason I chose 30 and 80 was like my way of, actually it's probably better than averaging for most of you, but it was my way of not having to deal with the average. We do 30 and 80. And the points on those originally were 50 and 200. Okay, so we have class today. We're going to talk about numerical methods. We have class next week, and then the week after that we have exam 4. Okay? And it doesn't give us a lot of time to talk more, that much more about MATLAB. We're going to do a bunch of MATLAB stuff today. It's actually not even really MATLAB, it's just numerical methods using MATLAB. The code we'll look at today will be simpler than most of the stuff we've done. There will be a homework associated with today. I'll have it out to you guys by tomorrow. And that content will be on the exam. Okay? Next week, we're going to talk about some stuff, and I'm not going to expect that to be on the exam. Okay? We're going to talk about object-oriented stuff. We'll talk about sort of software workflows, some random interesting topics. Right? So what that means is exam 4 is going to cover the same, mostly the same material, plus some questions about what we're going to talk about today, some questions about computer architecture, and that's it. Okay? So it gives you a chance to sort of re-shine on exam 3. That makes sense? Yeah. And to answer your question, is it cumulative? Yeah, I mean, everything we've done is, right? There's nothing that we've left behind really.
So we should expect, what, like a 6 hours?
What, you want to cut it back? Let us hope that I get it right this time. No. So I think we might go with, if it's the same scale, we'll do 2 problems and then some questions. I do not want it to be a 4 hours. Okay, let's take a break. We'll come back and talk about numerical.
It's a normal class period too, right?
It's a normal class period, yeah. It's the same time, same location. Yeah, it'll be in Canvas again. The short answer stuff will be in Canvas.